Now the phone is powered on, it has its correct files, it's registered to the call manager, and is ready to make and receive calls. Let's talk about inbound call flow when someone calls a company number. As a high overview, the call will enter the network via a voice gateway. The gateway will match the incoming call to a dial pair that forwards it to CUCM. And then CUCM will look up that dial plan to determine the destination. And then the call is routed to the correct endpoint, which would be the phone. So let's go and take a little deep dive into this. We have here at the top left, Annie. Annie is the automatic number identifier. It is the caller ID of the caller's phone number, and what we call the calling party. So this is someone external trying to call internal, trying to call our company. So the call goes through the PSTN. The PSTN will know where to send the number. We know what a PSTN is. It's the public switch telephone network. Now that will traverse through to our PRI line until it gets to our gateway. A PRI stands for primary rate interface. It's a line that is a type of digital communication line used to connect a voice gateway to the PSTN. So configuring a PRI line involves setting up the physical interface, specifying ISDN parameters, and creating dial pairs for call routing. Thing I want to mention in this diagram, if you look down at the bottom to DNIS, the DNIS, that's just the phone number the caller dialed to reach the destination. So it represents the called part or the target number. Okay. Now, when you configure your PRI lines, you will have to get settings from your provider to fully activate that PRI line for service. So the call has hit our gateway and our VWIC has stopped the actual voice of the call because the call doesn't know where to go. And the signal actually continues through our network, our voice gateway, to get the permission for the voice. So a router has the voice capability. So a router has this voice WAN interface card, the VWIC. And it's basically just the specialized module that allows routers to connect to the PSTN using digital circuits like T1, E1 lines. Okay. Now the signal of the call continue through our gateway and hit our ingress call leg. And you see a call leg represents one side of a call. The ingress leg is the part of the call that enters your network or voice gateway. This is the first stage of the call. So the gateway matches the incoming call to an ingress dial pair to determine how it should process the call. So just to look at this dial pair here, we have the name, dial pair voice, 100 POTS. Now 100 is arbitrary. We can name that, we can have any number. Dial pair is saying we're creating this dial pair and it's voice. We have to put dial pair voice. 100 anything. POTS is saying because we have a T1 line. It doesn't have to be POTS. It can be VoIP, which means we have a SIP line, a virtualized line. But we don't. We have a circuit line, so it's POTS. Incoming call number and a dot, a period, which is a catch-all. It only looks for the DNIS, and the dot is any number. So incoming call number could be any number. And direct inward dial, it basically just says that the number dialed is complete and do not need a second dial tone. And this is really to prevent toll fraud. So these are like the main configurations, the main settings you'll have in your dial pair. You may have more, you may have less, well, not less, but you may have more, but you'll definitely have these three. Now, it's then packetized, putting those ones and zeros into an IP packet so it can traverse through our IP network. So we know that the voice is going to carry, but it's going to do some magic, some science behind it and packetize in ones and zeros, right? So it takes analog and converts them into digital and vice versa. It takes digital and converts into analog. And it will terminate digital signals and convert into IP packets. Now, the job this whole job is completed by the DSPs. And there are DSPs on the VWIC and inside the router, which is called PVDM. Now, DSPs stand for Digital Signal Processors, and they're just specialized hardware components on a PVDM. PVDM stands for Packet Voice Digital Module, and this is all installed in a Cisco router. So they handle the processing of voice and media streams, such as codec conversions, conferencing, and transcoding that's required for UC. Now, I do want to note here that PVDMs, DSPs, are reserved specifically for hardware media resources, meaning they physically handle the heavy lifting for tasks like media conversions that cannot be done in a software base. Now, the signal is at the egress leg. The egress leg is responsible for directing the call to its final destination, which should be either an external phone number via the PSTN, a VoIP endpoint over a SIP trunk, or just another router or gateway. Now, the voice gateway uses dial peers to determine how to handle that route to call during the ingress leg. So the outbound dial peer is going to provide key details such as the voice dial peer voice VoIP. And we can name that, again, anything. It could be 200. It can be 100 because 100 is our POTS, but it could be 200, 300, or 101, however you want your numbering scheme to go. And then VoIP, we know we're using VoIP because our network is IP based. Destination pattern. And in this example, we only own the last 4 digits of the number. So it's going to start with the first 7. So we're just going to put in the first 7 digits and dot, 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 4 dots for the numbers that are in that we own. Session protocol SIP v2 is the protocol we're going to use, SIP v2. The session target, the IPv4, is going to be the IPv4 address of the call manager sub and pub. So you can make 2 dial peers, but you can really have one for your publisher IP address and a second one for your subscriber IP address, which we'll get in more. So this creates that half SIP trunk to call manager, AKA the next hop. So it can be any, call processing node, but it'll most likely be to call manager. Voice class codec 8, which is just a top-down list of codecs we prefer to use. DTMF relay, RTP, NTE, and then SIP KPML. It's just dial tone negotiations. RTP is for SIP, or after DTMF, the relay, you can have H323 configurations. This right here is just saying the dials, the dial tone correlates with what you're pressing on the device. And then no VAD. No VAD is voice activity detection and is on by default. So you turn it off. We say bad is bad. So basically those syllables won't be lost there. We have half a SIP trunk, and we just need the other half to be completed from our call manager. So on our call manager, we must have some settings in place so that full SIP trunk can be completed and the signal can go through and make sure that they can allow the voice to have permission to continue on. Now, like I said, on CUCM, we need to configure some things. And we have to configure inbound CSS, which depending on the site, we're going to add a CSS that contains all the site phones. CSS is calling search space. That's like a call control. Significant digits, again, we own the last 4 of the numbers, so CUCM only cares about what we own. So we'll just put the last 4 here. And destination IP address. This is the address of the router gateway for usually the loopback address, because the loopback address is always up. But whatever IP address that is the router's IP address is what we're going to use here, the main one, not just any old interface. Okay, so we go into call manager, go into our gateways, and we add the above settings. Now the SIP trunk is complete, and the call manager now has the signal of the inbound call, and based on the last 4 digits, call manager knows where to route the call to. Now, call manager will send ring requests to the phone that the last four digits belong to and say ring. And the same time, call manager will tell the signal part, you and the voice can go to the phone when the phone is off hook, meaning when someone picks up the phone and says, hello, phone comes off hook. The person at the phone will pick up that phone. The person at the phone will pick it up and the phone will go off hook status. Call manager will send another message to the voice signal and say, go to the phone now, and the phone signal will traverse through the rest of the gateway, down through the switch, and hit the phone with a two-way voice phone call. So now the Annie and the Dinas are talking, having a good old conversation. Now at this time, CUCM is no longer needed. It is only needed when the DS needs to utilize media resources. Now, when we talk about media resources, types of media resources could be conference bridge, right? You might handle, multiple participants talking at the same time. An enunciator, where that plays recorded system messages for users, something like after hours announcements when the lines are down, or alerts for invalid numbers, whatever. Even music on hold server, which plays that music for callers to be placed on hold and they listen. Now, there could be some issues, and you would probably have to troubleshoot inbound calls. And some issues can include the call doesn't reach call manager, call fails to ring destination, call has no audio, and things in that such. So it's great to know the process of how to configure and set up in the inbound call flows so you can properly troubleshoot inbound call flows. And you can see here are some likely causes and some solutions to those causes. So just the summary, an end-to-end example of this inbound flow scenario. A customer calls your company support number, 1-800-588-2300 Empire. And then the call enters the gateway via a SIP trunk or a PRI. The gateway matches an inbound dial peer for, those numbers. The call is sent to call manager over a SIP trunk. The call matches a route pattern and forwards the call to the agent's IP phone. The IP phone rings and the agent answers. The media path is established and the conversations begin. So inbound calling flow is a backbone. It's the backbone of external communications in any organization. So as a UC engineer, your job is to ensure gateways are properly configured with inbound dial peers and SIP PTSN interfaces. Set up CUCM to handle incoming call numbers with route patterns and translation patterns. And troubleshoot any issues like missed route calls, codec mismatches, and call quality problems. I think you should do some practice questions and scenarios such as an inbound call fails to ring, the intended an inbound call fails to ring the intended extension. How do you troubleshoot? Okay, so now we know about inbound calls coming into the company and how that flow works. Let's talk about the flow of outbound calls when the company wants to call outside of the company. Now, just a high overview, when an internal user makes an external call, the endpoint sends the number to call manager. Call manager checks the calling search space, the CSS, and matches it with a partition. The call is then forwarded to the gateway via a SIP trunk, and then the gateway sends the call to the PSTN. Let's go over that and dive a little deeper. So you already know what ANI is, automatic number identifier. It is the caller ID of the caller's phone number. So the calling party, it'll be the internal. Let's say it's us. Let's say we want to call Pizza Hut. Pizza Hut's nasty. But let's just say we want to call Pizza to order a pizza for the call center workers. Okay, so we use our Cisco phone to dial the Pizza Hut that's down the street. So we dial the number, and then the number gets sent to call manager, and the call manager will check the route pattern, the route list, route group, and SIP trunk. Let's start off with the route pattern. A route is a string of digits that you can dial that'll allow you to call outside of the call manager cluster. So route patterns usually have a route list applied to it. And before we get to a route list, a route pattern typically begins with 9 dot because most companies use this to specify off of network calls, which is off net calls. So typical route patterns for US would look like 9.911 for emergency calls, 9 dot, and then you got the 7 digits for local calling, 9 dot, you got the 7 digits plus the area code for calling, and then you got the 9.1, and then the 10-digit number for long distance calls and international, right? 9.011 explanation. Okay. Now, when we talk about the dot, 9 dot, we call that pre-dot. And we basically just say, do we want pre-dot to be on or off, which drops the 9 before sending the rest of the number to the end device. When we talk about partitions in this section, this gives the administrator control of which people phones can actually reach a specific route pattern. When we talk about, again, route patterns are uh, connected to a route list. They have this route list to say, hey, which gateway or trunk do you belong to? Now let's actually talk about route lists, which is just a list of route groups. It just determines which call manager group your outbound calls will be processed with. Okay, again, this list tells the outbound calls which route group to go to. The route lists are usually applied to a route pattern that you know that. An example scenario, you have two different sets of route groups differentiated by service providers. One route group will contain Verizon's gateway and trunks, while the other would contain AT&T gateway and trunks. So again, it's just a list, and it's a top-down listing of route groups, and this is all for redundancy. Now we talk about the groups. When we talk about groups, it's nothing but a group of gateways and trunks as processed top down or circular, right? It's where you reference a gateway or a trunk for outbound calls to take place. Now they are configured in an orderly fashion. So first in line is the first to be processed. And like I said, they can either be processed top down with the first one always starting at the list. If it's unreachable, go to the second and third. Or it could be circular, where you go down the list for each request until reaching to the bottom and you just begin again. Now, top down is commonly leveraged for redundancy, and circular is leveraged for load balancing. So make sure you know when to apply. So then the SIP trunk, you have to configure that to the gateway. And the SIP trunk to the gateway is just making sure that there's a destination IP address on call manager, which is that loopback address of the route or the gateway. You're going to see me interchange router and gateway throughout this because they're the same thing. A router is a way out of your network. A gateway is a way out of your network. They can be used interchangeably. So just to recap, because you configure this, you kind of have to configure it backwards, right? So the first thing you do was create a gateway or a SIP trunk. So you would go into Call Manager and create that gateway or SIP trunk. You would create a route group and then add the above created gateway SIP trunk. And then you would create a route list. And you can select SLRG for route group, which is standard local route group, or just select the route group that you created. And then you would create a route pattern, for example, 9.911, and select the route list that you created. Now it processes top to bottom, but in order to configure it from bottom to top. But now that it processed through, it knows the route pattern, it can call outside the network, it knows the route list, it knows what groups of SIP trunks and gateways to use, and then it started with using that whatever one was recommended first, and now it goes to the gateway. The call hits the gateway. When the call hits the gateway, we know we have both ingress and egress call lanes. So starting with the ingress leg, the ingress is in our network. We're going to do dial pair voice, give it a number, let's say 100. And instead of saying POTS, we're going to say VoIP because we're using IP network. And we know incoming call dot is the catch-all. Session protocol SIP version 2, the protocol we're using. The voice class codec 8, a list of codecs. We have our DTMF, which is a dial tone, config settings, and no bad. Like I said, bad is bad. We do not allow the connection to stop when no voice is detected because it will hang up the call. All right. We know what a dial pair is to identify call source and destination endpoints and define the characteristics that are applied to each call leg in a call connection. Now, a call leg is just a logical connection between two routers or between a router and a telephony side, like we have a PSTN. Okay? So if the call have went through the leg, the egress leg hits all the necessary settings, the call will be sent out to the PSTN and the PSTN will route to the DNS, which is our target. Troubleshooting outbound calls can be something in this sort, like call doesn't go through. It's likely not matching a route pattern or a CSS misconfiguration. And you just want to verify that route pattern in the CSS settings. There's a bunch of different scenarios. These are kind of the simple and most common. And it's easy to troubleshoot and attack when you understand the call flow and how it is configured. Just as a summary, outbound calling flow involves multiple steps. And as a UC engineer, you must know how to configure a dial plan with route patterns, translation patterns, CSS, and partitions. Set up gateways with proper dial pairs and codecs. Prioritize voice traffic with QoS to ensure clear communication. And troubleshoot any call failures that happens in the system, focusing on signaling, media, and connectivity. I suggest you do some questions, some practice on some questions and some scenarios, such as a user dials 9.1 and the rest of the number is arbitrary, but the call doesn't go through. What steps would you take to troubleshoot? Just remember, outbound calling is a critical part of Cisco UC, and mastering it ensures you can design and maintain a reliable communication system.